Good morning students. Today we are going to discuss about an oscillatory circuit. So what is oscillatory circuit? A circuit which produces electrical oscillations of any desired frequency is known as an oscillatory circuit. So this circuit consists of two reactive elements named as inductor and capacitor. Okay, are connected in parallel with each other. So this such a circuit is also known as LC circuit or tank circuit. So both the reactive devices are capable of storing electrical energy. So it is well known that fact that an inductor stores electrical energy in its magnetic field whenever current flows through it. Similarly, a capacitor stores electrical energy in its electric field whenever a voltage is applied between the two terminals. Okay, so both the reactive elements are supposed to be an ideal one. So now we shall discuss the how the LC circuit, that is tank circuit, generate oscillations. Okay, suppose a capacitor has been charged from a DC power supply, that is DC voltage source, with the polarity as shown in the first figure, figure 1. As the switch is open, it cannot discharge through the coil L. Okay, so when the switch S is closed as shown in the second figure, the capacitor discharge through the coil L. So the discharging is due to the flow of electrons from the plate 1 to 2 through the coil L, as indicated by the arrow in this figure. And this current flow sets up magnetic field around the coil. This magnetic field stores the electrical energy released by the electric field. Because of the inductive effect, the current goes up slowly towards the maximum value. So this situation occurs when the capacitor is fully discharged. At this instant, the electrical energy stored in the capacitor becomes zero. Okay, and the energy stored in a magnetic field is maximum. In other words, we can say that the electrical energy across the capacitor is completely converted into magnetic energy, field energy around the coil. Once the capacitor is discharged, what will happen? The magnetic field around the coil begins to collapse and produces a counter EMF. So according to Lenz's law, the counter EMF keeps the electrons moving in the same direction, so that this again charges the capacitor through in the opposite direction. Okay, so shown in the third figure, that is figure C. So it may be noted that the plate 1 has become positive, whereas the plate 2 is still negative. So when the capacitor is charged completely in the opposite direction, the magnetic field around the coils is also collapsed completely. So at this instant, the energy previously stored in the magnetic field has now converted into electrical energy stored in the electric field of the capacitor. So after this, capacitor starts discharging in the opposite direction, so that the electrons now move from plate 2 to 1. From here, see, look at the fourth diagram, that is D diagram, from plate 2 to 1 as shown in the figure. So the electric field start to collapsing, whereas the magnetic field starts building up again in the reverse direction, which is shown in the figure. This is the fourth figure. So this figure shows the condition when the capacitor has fully discharged once again. So the above mentioned sequences of charging and the discharging of a capacitor results in an alternating motion of electrons or an alternating current. As a result of this, energy is alternatively stored in an electric field of the capacitor and magnetic field of the coil. So this interchange of energy between the capacitor and inductor continues to be repeated. There is, as a result, the production of electrical oscillations. Okay, so there are no power losses in the tank circuit. The waveform of the electrical oscillations will be undamped. That means that is constant amplitude. So, however, in practical tank circuit, the waveform of the oscillations is damped. It is a decreasing amplitude. So, it is because of the energy lost by the L and C, that is inductance, inductor and capacitor elements, which may take place because of the two reasons. The first reason is some energy is lost in the form of heat produced in the resistance of the coil, connecting wires, and within the dielectric material of the capacitor. And second reason is some energy is lost from the circuit due to radiation in the form of electromagnetic waves. As a result of these losses, the amplitude of the oscillating current in the tank circuit decreases gradually, and eventually it becomes zero. Okay, so the waveform of such oscillating current will be of the sustained oscillations.